In this lesson, we're going to be looking at how to find the trigonometric values using the unit circle. This video relies on an understanding of radians and their positions. So if you have not looked at the introduction to the unit circle video, please do that first, because you're going to need a basic understanding of how radians work and positions on the unit circle before this is going to make sense. So let's look at some review. So far, when you've used trig, I'm sure you've used right triangles especially. When we look at a right triangle, we have the hypotenuse, the opposite, and the adjacent sides relative to our reference angle. Our sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. This relates to what we are doing with the unit circle. If we imagine that the unit circle is shaped like this, with the hypotenuse being the radius always being equal to 1, because that's always the way that a unit circle works. So from the last lesson, you'll remember that we always begin at the initial position, which is the 3 o'clock position, and we rotate to our terminal arm, here highlighted in red. So you can see that this actually forms a right triangle, with the opposite being the y value and the adjacent being the x value of the point at the end of the terminal arm. So let's begin filling in some values. We'll begin at our initial position, and if we imagine the point at the end of the terminal arm having a coordinate pair, that pair would be 1 and 0. We are 1 distance away from the origin in a positive direction in the x and 0 in the y. When we rotate through quadrant 1 to the vertical position, x is now 0, and our y position is now 1 away from the origin. Rotate through quadrant 2, and we come to the position -1 and 0 at the end of our terminal arm. Through quadrant 3, and we get 0 and -1, and back to our initial position. Now let's look at the intermediate positions. So our 45-degree angle. Imagine we have a right triangle with a hypotenuse of 1, a 45-degree angle in one corner. Now this is going to make it a equilateral triangle. So we can use Pythagorean theorem, a squared plus b squared equals c squared. So we know that the sides are the same length. So we really have a squared plus a squared equals 1 squared, because the hypotenuse is 1. So this is the same as 2a squared equals 1 squared, or just 1. If we divide both sides by 2, we have a squared equals 1/2. Take the square root of both sides and we get the root of 1 over the root of 2. When we rationalize it, we get root 2 over 2. This means that both of our sides are a distance of root 2 over 2, making our coordinate pair root 2 and root 2. If we mirror across the y-axis, we see that we get the same values in quadrant 2, except that our x value on this side is negative. Our y is still positive. If we mirror across the x, we now have the same values, except both x and y are negative. And in quadrant 4, we have the x being positive and the y being negative. So now let's start looking at breaking this down more. We'll look at our 30-degree angle. We can use the same principle, but let's begin by looking at an equilateral triangle. So all of our side distances would be 1, and all of our angles would be 60 degrees. If we split that in half, we end up with two triangles with 30 and 60 degree angles, hypotenuse of 1, and one side being 1/2. So let's break this over here so that it looks like the same shape we're looking at in the unit circle. Again, we can use Pythagorean's theorem. Let's fill in our values, and we will work the equation the same way, and we will find that a, or the x value, the bottom of this triangle, has a distance of root 3 over 2. So if we look at the coordinate points for this position, x value is root 3 over 2, y value is 1/2. Again, we can mirror this across the y, getting a negative root 3 over 2 and 1/2, into quadrant 3 for negative root 3 over 2 and negative 1/2. and into quadrant 4 for positive 3 over 2 and negative 1/2. So let's look at our 60-degree angles now. This is going to be very similar. We're going to break it apart. Let's put the triangle the other direction now. We'll use Pythagorean's theorem again. Break it through. You'll see this looks very familiar. And we end up with our opposite this time being root 3 over 2 and our adjacent being 1/2, meaning that the points for this top point here are 1/2 and root 3 over 2. Mirrored across the y to get negative 1/2 and root 3 over 2. Across the x, and we get negative 1/2 negative root 3 over 2. Mirrored across the y, and we get positive 1/2 and negative 3 over 2. So here's some tips for remembering how to fill in the unit circle yourself. Let's begin with our first value with our y. This is, you could think of it as root 1 over 2. Our next one is root 2 over 2, root 3 over 2. Coming down on our x's, we have root 1 over 2, root 2 over 2, root 3 over 2. So if we remember that the y's go up, root 1, root 2, root 3, the x's come down, root 1, root 2, root 3. All of them are over 2, and in quadrant 1, they are both positive. We can mirror them across the y-axis into quadrant 2 to get all of the same values, except this time all of our x's will be negative, our y's will be positive. We can mirror them across the x-axis to fill in quadrants 3 and 4. In quadrants 3, both x and y will be negative. In quadrant 4, x will be positive, y will be negative. And there you have it, the completed unit circle. Let's use this to find our trigonometric values. Going back to what we were doing before at the first slide with hypotenuse, opposite, and adjacent. Remember that cosine is adjacent over hypotenuse. In this case, the adjacent is always x, hypotenuse is always 1, meaning that the cosine is just equal to x. The sine is opposite over hypotenuse. Again, opposite is always equal to our y value, hypotenuse is always 1, so sine is really just the y value. Tangent is a little bit trickier, it's opposite over adjacent, so that means y divided by x. Let's look at some sample questions. What is the sine of pi over 6? Now remember that the position of pi over 6 is here in quadrant 1, and because we're looking for the sine value, we're looking for the y value, which in this case is 1/2. The cosine of 7 pi over 6. So 7 pi over 6 is over here in quadrant 3. Because we're looking for the cosine, we're looking for the x value, which is negative root 3 over 2. What is the sine of 5 pi over 3? Well, 5 pi over 3 is down in quadrant 4. We're looking for the sine, so it's the y value, which again is negative root 3 over 2. What is the tangent of 3 pi over 4? Well, 3 pi over 4 is up in quadrant 2. So this, remember, is y divided by x. Y is root 2 over 2. X is negative root 2 over 2. So when we divide those, we get negative 1. The cosine of pi. Remember, pi is over here between quadrants 2 and 3. Our cosine value is just our x value, so that is negative 1. And our last one to practice is another tangent. This is the tangent of 11 pi over 6. Over here in quadrant 4. So this is y divided by x. If we take negative 1/2 and we divide that by root 3 over 2, we get an answer of negative 1 over root 3. So that is the end of these example questions. Please take some time and work through the practice questions, work through the worksheet, take some time to really get to understand how this works and to get fluent with it, because you will be needing it in the future. In this lesson,